Good evening. My name is Sean Sullivan, and this is the finish line. This is my final presentation for Data Management System Project. This is for CEN 3024C, Section 31774 at Valencia College for the summer of 2025. So let's dive in. First, let's talk about what this project is. This is the Disk Information Storage System, or DISC. I'm going to go ahead and actually pull this over to the side, make sure we don't miss anything. Uh, The disk is a database management system that stores disc golf discs, and it's specifically geared towards people who spend time locating lost discs on a disc golf course. Typically, you lose them in the woods or in the trees, a lot of times in the water. So people will rake these ponds that are on disc golf course, or dive these ponds on disc golf course, and find large amounts of discs. And the only system available to get them back to people is either you look on a local Facebook lost and found page and hope to see that your disc has been posted, and you're on that Facebook at that right time when your disc is posted saying, hey, is this yours or is this anybody's? And you can claim it that way. The other option is to put your personal information in Sharpie on the bottom of the disc, and 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 that's a little bit, it's a little unsavory for some people. I'm not a big fan of putting my phone number out there for the world to see. So um, I always thought that there was an opportunity here to create an application that give you a unique user ID that obscures your personal information, and then also generates a serial number or an ID number for each disk that you submit as belonging to you. And then you can take that ID number, write it on the disk in Sharpie just like you would your phone number in the current system, and then people can see that ID number, enter it into this application for lost and found disks, and it will be tied to you, and it will send you a notification, hey, someone found your disk. So this project is kind of a spin off of that, or a walk before you run version of that. Hopefully I get to take it to that point one day. But uh, the main object for this was always going to be disks. Here you can see all of the different attributes that a disk will have and did come to have. The functional requirements are basic CRUD operations. Then also I added in searching records by phone number. I also added in towards the end of the project, because it was so simple to implement and seemed intuitive, searching by last name. And all of these functional requirements that I've come up with are, full disclosure, I used to be one of those people that raked and dove ponds, so I pulled on my personal experience to figure out what functionalities would be most beneficial to me if I were still doing that, and in my experience. So also calculates resale value based on the MSRP and the condition of the disk that you enter into one of the attribute fields. Also calculates total value of disks returned to owner. So it takes the MSRP. If you mark a disk as returned to the owner, it keeps a running total of how much money you've saved to people by returning their disk back to them. And then also rakers and pond divers, if a disk sits in their inventory for long enough and no one claims it, typically what they'll do is they'll either take it for themselves, or they will sell it to local vendors for profit. So there's also a functionality that calculates the total revenue from disk you sold to a local vendor. The database is always going to be changing throughout the different phases. It was in memory originally when it was a command line interface GUI, and then eventually moved to a standalone database after that. The UI original functionality and planning was based off of this Java UI that I built in Scene Builder and Swing for an earlier Java, I believe, Intro to Java class. Um, in another semester. This was kind of the jumping off point, but by the end of it, it was far beyond this, as you'll see in just a minute. So that was the initial uh, information gathering and project requirements gathering phase. Then I moved on to implementation. The implementation plan originally was to have three classes. It was going to be a very simple application, three classes: a main disk object class, a raker class, which is just thematically named, but it's actually a controller or an admin class that has all of your business logic and your CRUD operations to interact with the database. And then lastly, a the disk app itself, which obviously starts the application, which has the main method. Um, Funny enough, when I defined the architecture pattern, I said is not intended to be web-based. It ended up being web-based. And I'm based the or the architecture based off of layered architecture with a UI layer, a core logic layer, and an actions layer because I've been doing that a lot in my advanced web development class. So kind of how my brain's wired right now. So that was the schema or the architecture that I planned on using for the application itself in the end. It was utilized also in the command line interface version. So kind of all the way through, we still had a layered architecture. So it was nice to have that consistency, even though it really morphed in its function afterward. So last thing, test plan. We created a test plan. Originally, when it was a simple application with just 3 classes, I planned on doing branch coverage. So all of the logical eventualities or all of the branches that could potentially be touched through the different functions were to be tested using JUnit tests, and I did implement all of those JUnit tests in the test plan phase or in the actual testing phase. But after I moved to a Spring REST API and a React front end, a lot of that validation and a lot of the error handling is built into the functionality of Spring. So a lot of the crash potential that you have there is mitigated by Spring itself. So the testing for the final product was admittedly not as robust. So don't know whether that's incorrect or correct, but that's where we ended up. So we'll start from the bottom up on the actual final product. The database itself is a 3NF relational database with 4 tables, one being disks. Each table, or the main one being disks, the main table, or sorry, each table has a primary key. It's an ID number, it's an integer that is auto-generated and unique, hence primary key. The 3 other tables, molds, contacts, and manufacturers, all are foreign keys to the disk table. You can see here marked by these orange or dark colored diamonds. The rest are your basic attributes that are associated with the disk object, or entity is what it's called, or model, it's what it's called in the Spring REST API. And then lastly, we have this calculated value for resale value. Molds also has one foreign key related to manufacturer, and we'll see that come up later on in the presentation. So this is the schema for the database. 4 tables, 3NF, pretty simple, nothing too crazy. So on to the back end. So let me go ahead and make sure that, yes, okay, so I've got my MySQL. All of that was built in MySQL, by the way. I've got it running, so we're good there. And this is the entry point from the database to the backend management. Is these repositories. Spring allows you to create interface repositories that extend this JPA repository class, and it is phenomenal. JPA repository essentially eliminates the need for you to type out all of your boilerplate SQL statements like get all or find by, etc. It generates them all for you. And then it also has a functionality where if you use the proper syntax when you're naming a function and pass it the proper variable, it will auto-generate your SQL statements for you there as well. So, for example, find by contact underscore last name tells JPA that you're going to be using the contact table, you're going to be using where last name equals, and then you pass it the argument contact last name, and it generates the entire SQL statement for you, or the SQL query for you. Unfortunately, I say that to say that I figured out these repositories aren't usable based on the project requirements. This project requires a dynamic login page for the user so that they can supply their database information or their local database information. And I figured out during testing that Spring, when it initializes, also immediately starts scanning for your entities, your repositories, and also scans your local system for database login information. And it uses it based off your Windows system login. So I was trying to implement this dynamic login page, excuse me, and it was giving me errors that there was already a login cached in the memory, and it was from my system information. So what I had to then do was disable all of the functionality I just described to you. So the entity managers or the object managers, the repository managers, the JPA repository, auto-generating SQL, um, and I disabled it on initialization and then initialized it myself in this custom data source manager page after the user provided their login information. So once they provide their login information, it calls this function to initiate the data source and sets up the database, sets up the entity manager, and then sets up the JPA functionalities so that you can interact with the database. I still didn't have the auto generate functionality for SQL queries like I described earlier. I had to manually enter all of my SQL queries now, but generating this JPA Hibernate allows you to interact with the database itself. So had to do all that to overcome the requirement for a dynamic login page. Um, the next level of the database is the service layer in a Spring API. Um, you can see here, this is the disk service page. This contains all of your business logic and validation logic that you might need. Like I said, you can see there's a lot of commented out code because this was based on the fact that I was going to be able to use a repository. Didn't work out, so I had to go back in and refactor. You can see the create disk functionality, get disk by attribute, which that's for saved or for returned or sold. Um, there are other things. There's also a disk validator class that is specifically for the import from file functionality. You can see that I did a disk validation class, and this is strictly for all of the text inputs that are passed to it to the function because you can't use the built-in lombok, etc. for functionality to validate those string inputs. So this entire class is just a utility class used in this specific function. Um, and then also something I learned along the way, just a side tidbit, if you're going to create a table in your database, you better create a repository for it. You better create an object for it. You better create a DTO or data transfer object for it. These data transfer objects are what allows your React or web-based front end to send JSON. It gets converted through these data transfer into these data transfer objects that can be passed in between the layers of the backend, and they essentially allow you to move data from the front end in JSON to the back end as a Java object, and then eventually can be converted if the logic or if the functionality is there that it's being used for to create your final disk object in your database. So we've got contact, one for creating disk, one for updating disks, one for import results. You'll see that functionality later. Manufacturer and mold tables have a data transfer object, and then obviously the disk itself has a disk transfer object. The attributes of these classes or these objects also determine what information can be displayed on the front end. If it's not included in this data transfer object, it won't be displayed on the front end because your front end won't have access to it. So the service layer and every layer uses these data transfer objects. The mapper is just that. It contains the functions for transferring or transitioning these data transfer objects to their different states, whether it be as a data transfer object or moving it to a JSON file on the front end or moving it to an actual disk stored in the database on the back end. And then the last layer of a Spring backend is the controller. There are multiple controllers here. This one is for database connection. This one is for disk itself. This is the one that does most of the heavy lifting. And all a controller is a endpoint for your backend to connect to your front end and vice versa, your front end to connect to your backend. It's all done through posting from the front end web page. So when your web page posts, it sends to the backend an HTML package with a URL header. The URL header is transferred by this controller. Obviously, anything that ends in API/disks is designated for the disk controller. Spring manages all of this and routes it based on this information. And then post mapping automatically goes to this function. Get mapping with no additional information automatically goes to the get all function, and so on and so forth. You can designate URLs from the front end to be passed to the back end so that they interact with the proper functionality on the back end. And this is how it all interconnects your front end and your back end to create a working application. You can see that there's several: find by last name, find by phone, delete a disk by ID. So these are all functionalities that are available on the front end, and this is the logic on the back end that they get routed to. So with all that said, front end. That's not the front end. This is the front end. I went with React. Never coded in React before, but it's really just a JavaScript library that allows you to dynamically update web pages so there's no reloading. So how React works is you create a function, you use hooks and states to then hook into functionalities in React, and the state is the state of the web page or the information displayed on the web page, and React on the back end handles, or under the hood handles, all of these states updates. So when you declare a variable in a function in React, you declare the variable name, and then you declare the name of the function related to updating the state of that variable, and React generates all of the information in the function for you. Fantastic. And then you set it equal to a state. Um, and here you can see that null 3306, this is headset cutoff. This is the login page that you'll see in just a minute. So all of the initial states are set to blank except for the port, and then the rest of this JavaScript is just normal JavaScript that you would use to handle events. And then the return statement for a React function is the web page itself. So React under the hood calls this function anytime a change is made on the web page. You're typing, you hit a submit button, etc., and it always returns out updated values of the web page itself. So that is how React works. And the main class that you really want to be concerned about, this is the fork in the road. This is how everything gets routed to a specific web page in a React front end. So without further ado, let's take a look at the final product. This is kind of crazy that this all came off of an original in-memory hash map and command line GUI. So let's take a look. Here is the executable jar file. I could run it from the command line, but it's just more convenient to click it from the actual folder itself. So we already know that our server is running in our services. That React is now running in the back end. Fun fact: I ran into some trouble when trying to get this video together for the final product. When you visit a web page enough in Chrome, it doesn't just save the URL, it also caches the routing for that web page. So even if you update the directory or the routing for the web page, Chrome will force the old saved in cookies and cache routing and take you to your stale or old web landing page. So I was scratching my head for a long time trying to figure out why I had updated my landing page to go to this dynamic database login, and it was still taking me to the old landing page before I updated it. Finally dug out and found in a random Stack Overflow post, I think, that Chrome can mess you up like this. So the only way to fix it is either open in incognito mode so that you don't have any browsing history, or clear your browsing history so that it doesn't auto override and direct you to a stale or old landing page. So I say all that so that I can pull this up. Localhost, it's hosted on port 880. Here's the landing page for the app. It gives you the opportunity to enter in your local database information. Mine is root. Password is this. Please type it right the first time. And here's our main menu for our disk app. You can see that we have all of the CRUD functions. Add a disk from a file, delete a disk from your inventory or your repository or your database. View all your disks, view your return disk, view your sold disks, search by last name, phone number, and update your disk information. So let's go through all this functionality. You can add a disk. These dropdowns are linked directly to my tables and my database because I wanted this functionality I'm about to show you. When you pick a disk manufacturer, uh, it won't let you select a mold until you select the manufacturer because the molds are uh, the manufacturer ID is a foreign key for the mold table so that I can have only molds available to the manufacturer you choose or created by the manufacturer you choose as options to avoid any bad data or corrupted data in your tables. So we'll do a scorch, plastic champion. As you can see, I've tested this a lot. It's got some auto populations. Condition will make it a 4. Description, overstable distance driver. Why not? First name is James. Last name is Madison. Phone number 334 8675309. All right, found at what's another course? Trinity. Trinity North specifically. Oh, whoa, hey, easy. H key. And the MSRP will set that at $16.99. So click Add Disk. You get an alert saying the disk was added successfully. Fantastic. Click OK, and we can go back to the main menu. You can view all disks here. So this is every disk in the database in a table format with all the information for the disk. If we scroll all the way to the bottom, you can see that I've tested this out a lot. So my disk database is robust. The one that I dumped is just the first 20 disks, so yours will not look like this, Professor, when you test it. So all the way at the bottom, we can see that the one we just added, James Madison's disk from Trinity North, 8675309-334. So there's that. That worked. Next, import disks from a file. So this is a file that is delimited by hyphens, just like in all the other tests that we've done a mass import with. So we'll use that, click import, and then it tells you which lines were successfully imported, which lines failed to import, and then why. So wrong number of attributes. I went ahead and put some in there just to show the functionality. And then it also gives you the ID of the disks that were just created so that you know where to look. So we'll go back, view all disks, and let's find, so where is disk 173? These aren't in order. I should add that functionality in later. So here we go. We've got disk 173 that was just recently added. So there's our import function working. Delete a disk 173 that we just added in. Delete. So it gives you a message saying, hey, it was deleted successfully. If you put in a number that doesn't exist, I know that disk ID not found. So let's view all disk again, and we're going to control F this because there's so many of them. 173. Nothing. Not there. So that functionality works. Next, view disk you've returned. So these are all of the disks that have been marked as yes in the return field or the return attribute in the disk table. And then also I added in my calculation feature right here. So the total MSRP of return disks, and this is the sum of all of these MSRPs of disks that are marked returned. It's a running total. So this value will update anytime a return disk is added. So just conveniently placed. Fantastic. You can review all your sold disks. Here is, these are all disks that are marked sold, yes, in the sold value column or the attribute column. And this shows a total revenue from sold disks. This is the sum of all of the revenues you see here for resale values, I'm sorry. And this dynamically updates as well. Search by disk last name. What did we just put in? We put in Carter? Jimmy Carter? Or was Jimmy Carter already in there? Oh, Jimmy Carter. Oh, there's an Olivia Carter too. How about that? So found everybody with the last name Carter, or every disk with a contact name with the last name Carter. As you can see here, that functionality does work. Here's Jimmy Carter, by the way. I think we actually used Madison, so let's prove that. There's James Madison. Okay. Search by phone number. That one was 334. Oh, 334 867 5309. Search. And it looks like John Smith also has that same phone number. I wonder which one's the real guy. So John Smith, James Madison, that functionality also working as intended. And then lastly, update disk information. Disk ID, let's go with 2. Load. So here we go. We got Jimmy Carter here because I've updated this in a previous video where my mic was turned off. So I recorded all of this before with my mic off. So what we'll do is let's change this to Proto and the color to green for disk 2, and the name will be Amanda Clark. Sure. It's marked as returned and sold. You can change these at will, but I'm going to leave them like that. We're going to update the disk. Gives you a validation message saying, hey, you updated it. Good job. So let's go take a look at disk 2. Here it is. It's now Proto Green Amanda Clark's disk. So that updating functionality works. And I believe that is everything. That's the whole application, top to bottom. Let's talk about those final questions. Let's go over real quick. What were the things that I learned? Through this process, I realized just how important the planning phase of the SDLC is. I spent a lot of time in the implementation of the GUI and of developing the REST API front back end with the React front end. On writing functions that actually ended up not making it into the GUI. Specifically, I had individual functions at each layer, the controller layer and the service layer and the repository layer, for individually updating the sold status of the disk, the return status of the disk, and the contact information of the disk. And had I planned it out properly in the beginning, in the planning phase, I would have realized that it doesn't make sense to have individual pages for those. Why not just put all the information on one page and update it? So I really, really learned just how important it is. Also, I kind of went through the later phases of the project willy-nilly. I didn't really put a lot of stock into figuring it all out in the front end. I thought to myself, well, for the GUI, like, I'm just going to use JavaFX or I'm going to use Swing. I'll figure it out when I get there. But then when it came time to actually make that decision, I told myself, you know what, this is an opportunity for me to create something that I could use in my portfolio and discuss in the future with potential employers or with other people in the software space, and it's something I could be proud of. So pulled the trigger, bit off way more than I probably should have. Spent a lot of late nights trying to understand Spring and how it operates, understand React and learn React. I'm definitely no expert, but I at least have a somewhat handle on it, enough to at least create what you see in front of you. So I really, really, really just learned that just like all the textbooks that we've had and all of the discussions that you see emphasize, the planning phase is so crucial if you want to run an efficient and effective project through the system or the system development lifecycle. Really focus on planning, really have an understanding of what your GUI is going to look like, what your database implementation is going to look like, what your connectivity is going to look like. All of those things that I could have planned on the front end and save myself a lot of headache on the back end were lessons learned. Um, what challenges did I have to overcome? They were all self-inflicted. I think that not, like I said, not planning it on the front end and then deciding, hey man, why not learn REST APIs and and React? Seems like a good idea. Um, so you know, introducing myself to a whole new framework in Java, and then also um, a whole new front end development library was probably really ambitious, and the challenges of learning how things work and learning how React works and learning how and wrapping my head around understanding the different layers of a REST API and how they interact with each other and what the purpose of each of them is and what code belongs in each layer of a REST API was super uh, time consuming. Time consuming, but isn't really the word, but it was a lot to take on, is what I'm trying to convey. I spent 8 hours alone just reading documentation and trying to understand Spring and wrap my head around it, and leaning on resources from people that I know who are programmers previously, who are now Scrum masters and things like that, and then also online communities. Our class community. We have a class Discord that we kind of help each other out in. Um, yeah, that was the biggest challenge was overcoming what I didn't know about the framework that I chose to use. Um, the the early framework was super easy to understand, using command line interface, using basic Java objects. So potentially biting off more than I could chew was probably my greatest challenge, and then having to slog through self-learning all of these things that I implemented in this final product. And lastly, how can you take the knowledge of the software development lifecycle forward to future classes or a future career in software development? I think I just hit the nail on the head with that. It's the planning phase and understanding the full scope of your project and doing the requirements definition, doing outlining the scope, getting stakeholder buy-in, understanding use cases, understanding a good, clean UI from the beginning. All of that saves you so much work on the back end and really prevents scope creep, because obviously this is a perfect example of what scope creep looks like, because originally, as you could see from my original slides or my requirement slide, the UI was so basic, and the implementation that I thought I was going to use of 3 classes was so basic. Um, and then it got out of control and it ended up with this. I learned a lot, so I'm happy it did. But that's my key takeaway: is planning is so crucial um, in any system development lifecycle. If you get the planning right, it's going to save you so much headache on the back end. So I think those are my final thoughts. I really enjoyed this project. I learned so much. I created a product that I'm really proud of. I know that there's probably some more senior or more experienced developers out there that could just rip this thing apart and poke a lot of holes in it. But it's something I feel confident in. It's something that I can now take into my portfolio and discuss with future employers or with other people in the software community, and it's a good starting off point for the potential rest of my professional career. So, Professor Evans, I want to say thank you so much for all of your help this semester, and thank you for being understanding when uh, I went through some rough situations and being available to discuss anytime I needed help. Um, as always, I really appreciate your feedback. I look forward to hearing your thoughts, and hopefully you don't break my program in the process. So, um, again, thank you for a wonderful semester, and I hope if our paths never cross again, thank you.